Let's take a look at this question under its capacity and make sense of it. Now the question says ice at what minus 5 degrees Celsius. So let's have this our transition of heat flow. So we call that the transition of heat flow. So that's THF. So the transition of heat flow. So now this is on the ice. So the ice, the temperature here is our theta 1, which is minus 5 degrees Celsius. So that turned to ice at theta 2, which is at 0 degree. So that melted ice now turns to what? Water at the same temperature. So theta 2, which is at 0 degree. So the heat supply is theta 1, heat supply is of theta 2. So just follow me now. Ice at minus 5 before we reach ice at 0. For this ice to now melt to water at 0 degree. So here what happened? We have the change in temperature. So the heat involved here is sensible heat. Why is it sensible? Because there is what a change in what in temperature. Now look at this one. The temperature is constant. So we have what the heat involved here is latent heat because the temperature is constant. So we have what constant temperature as easy as ABC. So now say our quantity of heat used. So the total quantity of heat used is Q1 plus Q2 as easy as ABC. So our Q1 is MC delta theta. Our Q2 is what? MLF. So here we are having MC theta 2 minus theta 1 plus MLF. Since we are having the same substance, which is ice, the ice that will melt to water, so N and C theta 2 minus theta 1 plus LF. So let's supply the values. So the mass of water in gram. Now, another thing we need to note is this. Whenever the mass is given in gram, please take note of this. Normally, gram is what? Is non-XI unit of the measurement of mass. But look at the what? The constant, the specific heat capacity of ice. We also give you what in gram per gram. Look at this one, there's also gram here. So there is no need for what conversion. So that's what makes students to waste unnecessary time during what the examination. So in the down tutors and what we give tips on how to what to beat time during what the examination. Now, assuming you are giving our unit to be on joule per kilogram per Kelvin, I must convert this one to what? To Kelvin as well. So there must be what? Conformability in the unit used both the mass and what? The constant. Please take note of that. So in this case, gram, so no need about conversion so that you save my time. So here you have our 10. Follow me now. So our C specific capacity of ice is 2.1. The final temperature is 0. Our initial temperature is minus 5. Plus the latent is you have 336 as equal as ABC. So this gives us 10. You have 2.1. So 5 times minus plus. So 0 plus 5 gives us 5 as equal as ABC plus 336. So here we now move to have our 10. This one will give us 10.5 plus 336. So let's add up now. So our QT now equals to 10 multiplied by, so we add that one, 336 plus 10.5. So you have 346.5. So you have 346.5. So we multiply by 10. You have 346.5. That's option C. This is the Don't Tutorials where we play with physics. Like this video, share and follow us on all socials. Thank you.